This is 6.4, Transformations of Exponential and Logarithmic Functions. This will be video number 2. In this video, we're going to talk about those logarithmic functions. Okay, so before we get started actually graphing those, let's talk about what the parent graphs for logarithmic functions look like. Okay, we haven't had graphs that look quite like this, huh? So, we've had it to where we've had exponential growth, or we've had exponential decay, but the logarithms are reflected, is that graph reflected over that line y equals x. Okay, so if b is greater than 1, which is our base, okay, this is what it will be down like this. And now our asymptote moved, instead of being at the x-axis, our asymptote is now at the y-axis on both of these. So if I had exponential decay, because b was between 0 and 1, my base is less, or between 0 and 1 here, and so I'd start kind of up high on the y-axis, and then it would move down from there. Okay, so oops, one more. Now let's talk about those transformations that it makes. Now these are the same things we do for all of the functions we've had so far. If it's grouped with x, we move left and right, but we do the opposite. So if it says -4, instead of going left, we go right. Okay, and that's when x is within the log and that minus is in there in parentheses with x. If it's not in parentheses, that means it's just tacked onto the end, and that moves us up or down, and we do what it says. +3 goes up, -1 goes down. We are not doing reflection in the y-axis, but reflection in the x-axis is when the function is negative, so there's a negative out in front of the log, then it flips upside down. And also, if we have a multiplier in front of our function, that's a stretch or a shrink. So if it's greater than 1, it's a stretch. If it's between 0 and 1, it is a shrink. Okay, so let's give this a try on number 4. Okay, let's start off by graphing our initial function here, our f of x. Okay, I told you, for log functions, instead of the asymptote being the x-axis, it is the y-axis. Okay, so that's changed from our exponential functions that we've been graphing. All right, and let me get some points to plot. So I'm going to use my calculator, have it tell me those points, make it easier. Now remember, if it has a base other than 10, you have to go math, and mine has this thing that says log base down towards the bottom. Okay, if yours does not have this, you need to use the change of base formula, and you can just type that in here. Okay. So it'd be log base 2 of x, and I want to get my points. See where it has those errors? That's because the asymptote is on that side. So even 0, when x is 0, is an error because it never touches this asymptote. Okay, but we have 0.10, 2, 1, 3, 1.6, 4, 2, 5, 2.3, and we'll kind of see the gist as we go. So 1, 0, 2, 1, 3, 1.6, 4, 2, 5, 2.3, and you kind of see the curve starting. So I know it's going to come from here and go that way. Okay, so this is f of x. Alright, so let's state what's happening here to g of x. I have a negative out front and a 3. Remember, we don't count that as one number. We don't say, I have -3 out front, so it does this one thing. The negative reflects it, so it has a reflection. So I know instead of curving up like this, it's actually going to start from the top and curve like that. Okay, and that 3 is a stretch or shrink. Since it's greater than 1, we will have a stretch of factor 3. And I'm kind of running out of room there, sorry. Okay, And then log base 2 of x is still what we have, so nothing else changed. Those were our changes. And remember, whenever we have something out front here, if I'm going to use these points, I just need to multiply the y values by that number. Okay, so I'm going to end up with negative 3, negative 4.8, negative 6, negative 6.9, okay? Now, there was no shifting left or right, so I'm going to start at 0, 0, and I go 1, 0, still uses that point. I go over 2, down 3, over 3, down 4.8, over 4, down 6, over 5, down 6.9. So you can kind of see the curve starting here. And you just keep it going, and it does get steeper. Maybe not quite as steep as what I just did, but kind of kinked it right there, but that would be our graphs. And you could always, you typed in the parent function, you could always type in your other function. So if we did that, negative 3 log base 2 of x, and if I graph them both, there's my parent function. Of course, its colors are opposite of what I drew here. And then there's my g of x, okay? All right, so last one, let's do number 5. Okay, we got a little bit going on here too. So let's start with the what we're going to call our parent function here, okay? Again, it is going to have an asymptote on the y-axis, and that is for our log functions, okay? Let's get our points. So I'm going to come back to my graphs and clear what I wrote there. I have log base, and I'm just going to change that to 1/2. There we go. So I have the point 1, 0, 2, negative 1, 3, negative 1.6, 4, negative 2, 5, negative 2.3, and you can keep going if you'd like. Just scroll down. But I feel like I'm good because see, all of those are just approaching negative 3. Okay, so if I plot those at 1, 0, 2, negative 1, 3, negative 1.6, 4, negative 2, 5, negative 2.3, and I can see that I'm going to, and we just showed that we approach right there. Okay, so this is f of x. All right, let's list what's happening to f of x to get our g of x. So it has a 2 out front, so that is a stretch or shrink. It's going to be a stretch because it's greater than 1, so it has a stretch of factor 2. Okay, and then it has the base half, and then it has the x, but in with x, so it's in parentheses with x, it's grouped with x, it has the plus 4. So instead of going where x is a plus 4, we do the opposite. We go minus 4, which would be left. Okay, and what that does is that's going to move this asymptote left 4. So our asymptote is now here. There was no moving up or down, so that means instead of 0, 0 being here, I could say 0, 0 is right there. Okay? Now we did have a stretch of 2, so I need to multiply the y values by 2. So this becomes a negative 2, negative 3.2, oh yeah, sorry, negative 4, negative 4.6. Okay, so if I graph those now, but I'm going to graph these points now from where I moved. So this is 0, 0, so I'm going to go right 1 from that point, from that where it meets that asymptote. I'm going to go right 2, down 2. I go right 3, down 3.2. Right 4, down 4. Right 5, down 4.6. Okay, so if I draw my points, kind of looks like that. And there's g of x. Okay, so now I want you to go to the practice and finish it up by doing numbers 27, 29, and 30. submit it on Big Ideas, and then submit your score into Canvas.